Hello students, welcome to Maha Class 10. In this second part of mensuration formulae video, we are going to cover formulas regarding frustum and concepts regarding segment, sector of a circle with formulas. In part 1, we covered area and volume formulae of various shapes like cuboid, cube, cylinder, etc. Link for part 1 is provided in the description. Now, we shall cover these topics and related content. Here, you can see how a frustum is formed. A cone is cut by a plane parallel to its base. The top portion becomes a smaller cone, and the bottom portion that remains is called the frustum. The image shows a frustum of a cone, which is the part of a cone that is left when the top is sliced off by a plane parallel to the base. The dimensions are labeled as follows: h equals the height of a frustum, L equals the slant height of a frustum, R1 and R2 equal the radii of the circular faces of a frustum. Note that R1 is greater than R2, meaning R1 is the radius of the larger base, and R2 is the radius of the smaller base. The slant height, L, is the shortest distance along the side of the frustum. You can find it by using the Pythagorean theorem on the right triangle formed by the height, h, and the difference between the two radii, R1 minus R2. Slant height formula, L equals the square root of h squared plus the difference of R1 and R2 squared. Curved surface area of a frustum, CSA. The formula for the curved surface area is pi multiplied by the slant height, L, multiplied by the sum of the two radii, R1 plus R2. The total surface area, or TSA, of a frustum is the total area of all its sides, including the curved side and the two circular bases. The formula is the sum of three parts. Part 1. The curved surface area. This is equal to pi multiplied by the slant height, L, multiplied by the sum of the two radii, R1 plus R2. Part 2. The area of the bottom circle. This is equal to pi multiplied by the larger radius, R1 squared. Part 3. The area of the top circle. This is equal to pi multiplied by the smaller radius, R2 squared. So, the total surface area equals part 1 plus part 2 plus part 3. Volume of a frustum, V. The formula for the volume is volume, V, equals 1 upon 3 multiplied by pi, multiplied by the height, h. This entire product is then multiplied by the quantity in the bracket, R1 squared plus R2 squared plus R1 multiplied by R2. Sector of a circle. Definition. The central angle divides the circular region into two parts. Each of the parts is called a sector of the circle. The image shows a circle with center O. The two radii, OP and OQ, form a central angle, theta. Concept: minor sector. A minor sector is the sector of a circle enclosed by two radii and their corresponding minor arc. In the given figure, the region OPMQ is a minor sector. This is the smaller of the two sectors created by the central angle. Concept: major sector. A major sector is the sector of a circle that is enclosed by two radii and their corresponding major arc. In the above figure, the region OPBQ is a major sector. This is the larger of the two sectors created by the central angle. Length of an arc, L. If the measure of the central angle for the arc is theta, then the formula for the length of the arc, L, is L equals the fraction theta divided by 360. Then, multiply that fraction by the full circumference of the circle, which is 2 times pi times the radius, r. In simpler terms, you find the fraction of the circle that the arc covers, and multiply it by the length of the entire circle's edge. Length of an arc, L. Rearranging the previous formula. The proportional formula is L divided by 2 pi r equals theta divided by 360. Area of an sector. A. Concept. If the measure of a central angle corresponding to the sector of a circle is theta, measured in degrees, then the formula for the area of a sector A is area A equals theta divided by 360 multiplied by pi times the radius r squared. Note, the formula calculates the area of the entire circle, pi r2, and then multiplies it by the fraction that represents the sector's portion of the circle. Area of the sector A. This formula shows a simple proportion. The area of the sector A divided by the area of the circle is equal to the central angle theta divided by 360, the full circle angle. Direct recitation. The area of the sector divided by pi r squared equals theta divided by 360. Relation between length of an arc and area of the sector. Formula. The area of a sector can be calculated using the arc length and the radius. This is read as the area of a sector equals the length of the arc multiplied by the radius, all divided by 2. Note, if you let A represent area, L represent arc length, and R represent radius, the formula is A equals L times R divided by 2. Relation between length of an arc and area of the sector. This formula shows how the area, the arc length, and the central angle are all related by the same proportion. The full proportion. The fraction area A divided by pi r squared, the total area of the circle, equals the fraction arc length L divided by 2 pi r, the total circumference, equals the fraction theta divided by 360, the total angle. Direct recitation. A over pi r squared equals L over 2 pi r equals theta over 360. Title: Segment of a circle. Definition: a segment of a circle is the region bounded by a chord and its corresponding arc of the circle. The smaller region, shaded red and green lines in the figure, is called the minor segment. The larger remaining region is called the major segment. Concept: minor segment. The minor segment is the area enclosed by a chord and its corresponding minor arc. In the figure, the area labeled segment AXB is a minor segment. This is the smaller area cut off by the chord. Concept: major segment. The major segment is the area enclosed by a chord and its corresponding major arc. In the figure, the area labeled segment AYB is a major segment. This is the larger area remaining after the chord cuts off the minor segment. Concept: area of a segment for minor segment. AXB is a minor segment and AYB is a major segment. The diagram shows a circle with center O, a chord AB, and the central angle AOB labeled as theta. The region AXB is the shaded minor segment. Area of segment AXB equals area of sector OAXB minus area of triangle AOB. This demonstrates that the area of the minor segment is found by taking the area of the corresponding circular sector and subtracting the area of the central triangle formed by the two radii and the chord. Area of segment AXB equals area of sector, which is theta divided by 360 times pi times r squared, minus area of triangle, which is 1/2 times r squared times the sine of theta. In short, area of segment AXB equals theta divided by 360 times pi times r squared minus 1/2 times r squared times the sine of theta. This is the exact same formula as the previous slide, but it has been algebraically simplified by factoring out the common term, radius squared. The area of segment AXB equals r squared multiplied by the quantity pi times theta divided by 360 minus the sine of theta divided by 2. This factored form is often easier to use for calculation, as you only need to square the radius once, where r is radius of the circle and theta is central angle in degrees. Note that we have studied the sine ratios of acute angles only, so we can use the formula when theta is less than or equal to 90 degrees. We've successfully covered the slant height and volume of the frustum to the proportional formulas for arc length and area of a sector, and finally, how to calculate the area of a segment. Thank you so much for watching and keep up the hard work. Subscribe to Mahaclass 10 so you don't miss our next chapter review.